In the last video we were talking about voltage dividers, and let's just continue that discussion here with some slightly different components than in the last video. So what we have here is again a comparatively simple circuit built here out of battery. Comes in here, current's going to flow out of the red wire into the input of this resistor here, and I have a different resistor chosen than the 100 ohms I've been using quite a bit. This is a 10,000 ohm resistor, so I see a brown, black, and an orange band on this resistor right here. Now on the output of the resistor, I'm going into this little blue nub here, which is the thermistor. And as you recall, the thermistor has a resistance that depends on temperature. So it is a resistor just like this one does, but it has a very high dependence on temperature. The resistance changes very wildly as the temperature changes. So on the output of that thermistor here, we feed the other side of the circuit and background in the battery. So a 2-resistor circuit once again. I have my clip leads connected here. I have the green one going onto the red lead and the yellow one going onto the black lead. So to keep those out of the way, I have my voltmeter set up in voltage mode here. So what I'd like to do then is just want to monitor the voltage here across the thermistor. So there and there. So about 3.9 volts, about 4 volts. Remember, it's a 9-volt battery we're running off of. It's been returning about 8.5 volts. It's sort of dying a bit, but we can still use it. So we see once again the idea of voltage division, or the voltage fraction, is definitely occurring here again. 8.5 volts is the supply voltage, but across the thermistor it's 4 volts, so it's running at approximately 50% is the division of voltage, or the fractional voltage I'm getting across just the thermistor. Now if I pinch it with my hand to make it warmer, the 3.9 is going to start to drop. 3.8, 3.7, 3.77, and as I let go again, it's going to start to rise again as it returns to room temperature from my relatively hot pinch between the fingers. So what you see here is we have a circuit that there's a voltage in there that depends on the temperature. So I've effectively kind of made a digital thermometer, haven't I? Like for instance, I know that at room temperature, which is probably about 75 degrees where I'm sitting here, the voltage is about 3.85 volts. But if I raise this into the 90s, which is my body temperature or so between the pinches of my finger, it drops down to about 3.65 volts, something like that. So I can, if I then put it in ice and boiling water and got a bunch of corresponding points of temperatures that I know, I'd have myself a digital thermometer. But in either case, you see the voltage division happening again. We have a fraction of the voltage in here because of the way the resistances are set up. So I'm going to take the thermistor out. What I'll do now is I'm going to put in one of these potentiometers, which is a resistor whose resistance changes depending on where this handle is turned right here. So this is a slightly different one that I've been using here. I just sort of had it lying around, but I have some wires here soldered onto these 2 leads here. Now you can use your other resistor and one way, or your other potentiometer, or one way or the other, just sort of get it into the circuit, maybe with some clip leads or something like that. So I'll go ahead and put the potentiometer in the circuit by hooking in like this and like this, and of course these 2 wires that I'm putting in here are these 2 endpoints, never that cross the hole, just the 2, one on the end and one in the middle there, as we discussed in a previous video. And what I'd like to do once again is monitor the voltage just across the potentiometer. So I'll go ahead and put one clip lead here directly on the potentiometer. It doesn't have to be over on the circuit the way I've been doing it here, because the metal in the wires just connects them like they were at the same point there in the circuit. Something like this. So I have a voltage divider where one of the resistors is the potentiometer. So see the fraction has changed relative to the thermistor, which has been pulled out of the circuit. I'm at 6.2 volts. And as I turn this now, see the voltage changes. It's up to 6.89. Turn it the other way. It goes down to as low as about, well, almost 0 there. Look at that. And anything in between, something like that. So see, this is a real clear example of this voltage division, this 2-resistor voltage divider right here. I have the 10K in there, and I have this other one here, and see, I'm seeing the voltage, very nice change as a function of resistance. And that's what voltage dividers do. We can create fractions of voltages using these 2 resistors here. So in the next video we'll have a bit of a schematic. We'll drop back and look at a voltage divider and analyze it just a tad bit here. But in the last 2 videos we've seen several ways of creating voltage fractions, haven't we? Using fixed resistors of different resistances here, using a photocell, so we made a voltage change as a function of light intensity. Now we're seeing voltage change as a function of angle on a potentiometer, and using the thermistor we can make the voltage change as a function of temperature now. So we're able to create fractions of an otherwise fixed supply voltage in a circuit.